afternoon, students. Continues of the previous lecture series on signals and system. Let us have a small recap of what we have discussed in the last lecture. We have discussed about the signal and system and the classification of signal. Let me revise you about what a signal is. It is nothing but a quantity that refers to the physical phenomena, whereas the system is the entity that operates on the given signal so as to get the desired output. Coming to the classification of signals can be broadly classified into various types based on certain categories. Based on the type of variables, it can be defined as single variable or multivariable. Based on the types of signal, it is classified into continuous time and discrete time, energy and power, even or odd, periodic or non-periodic, likewise. So continuous time and discrete time means the signal or the physical quantity that varies continuously with respect to the time. There is no breaks or interferences in between the signal, whereas discrete time signal is a signal which can be measured only at particular intervals of time or at regular intervals of time. Next is even signal or odd signal. We know the even signal is always a cosine signal and odd signal is always a sine signal in mathematics. Here, unlike mathematics, here we can classify the signal as even or odd if the axis of the time signal is changed. Even then we'll get the similar signal, then it is called as even signal. Means x of minus t is equal to x of t means it is an even signal. If it is not equal, when the time axis is changed, immediately the amplitude of the original signal gets changed, means then it is odd signal, that is x of minus t is equal to minus x of t, that is odd signal. So further classification of signals will be discussed in this lecture series. Let us see what are they. Periodic and non-periodic signals means as we discussed in the topic of discrete time signal, the samples are taken at regular intervals. That is nothing but regular. You please remember the word regular. It is at regular time intervals. Then it is known as periodic signal, means at every 3 seconds the continuous time signal is sampled so as to get the discrete time signal, means then every 3, that is 0, 3, 6, 9, all the multiples of 3, that is nothing but the periodic signal. Okay, it is shown here, the continuous time signal x of t is equal to periodic if x of t is equal to x of t plus t, then it is periodic. So whereas the capital T represents the fundamental time period. The fundamental time period is T naught, then the fundamental frequency F naught is the reciprocal of T naught. Therefore, F naught is equal to 1 by T naught. Then the angular frequency is nothing but the sigma is equal to 2. It may be anything. So if we work on a problem, we can understand it clearly. So this is about the periodic signal. The condition for a signal to be periodic, or the condition for periodicity, is x of t is equal to x of t plus fundamental time period, capital T. For in case of discrete time signal, we know that if the signal is represented as a continuous time signal, it has to be noted as x of t, small t. Whereas if it is a discrete time signal, it should be noted as x of n. Therefore, x of n is equal to x of n plus capital N, where n is the fundamental time period here. If this condition is satisfied, then x of n is named as periodic signal. Unlike continuous time signal, here the fundamental period is nothing but n naught. Therefore, the samples are 2 pi n by n, which is designated as the fundamental time period, and it is dimensionless. The next type of signal is, under the classification of signal, the fourth type of signal is deterministic and random signal. And deterministic signal, from the name itself we can understand the signal can be determined or represented mathematically before it actually occurs, right? So for example, x of t is equal to 2 sine omega t is a mathematical equation. So the x of t is nothing but a sinusoidal signal. It can be understood from the mathematical equation itself. There is no uncertainty. You can predict the signal even it before actually occurs. This is the deterministic signal. Random signals, it is a great level of uncertainty. We can't predict before it actually occurs. For example, noise. We can't predict the noise signal will appear in this moment or later or at particular time. So these are the suitable examples for deterministic signal and random signal. The next classification is energy and power signal. What is energy signal? What is power signal? So this a signal can be classified as either energy or power based on the numerical value what we obtain after certain calculation. So the formula that is used to measure the energy is equal to integral x of t dt, square of t dt, minus infinity to plus infinity x square of t dt, if the signal is a continuous time signal. If it is a power signal, so as to measure whether the given signal is power or not, it is nothing but p is equal to limit 1 by t integral t x of t dt, square of t dt. So this is the formula to find whether the given signal is energy or power signal. In same way, if the given signal is a discrete time signal, we can identify the given signal is either energy or power using a formula E is equal to summation n is equal to minus n to plus infinite x square of n. And similarly for power, limit n tends to infinity 1 by 2n plus 1, summation n is equal to minus infinite to plus infinite x square of n. So any signal, we have discussed now from the calculation of the formula, we can identify whether the given signal is energy or power. And there is a condition so as to conclude whether the given signal is energy or power. If the resultant value of E is greater than 0 and less than infinite, only then you can say that the given signal is energy. Similarly, if the resultant power is non-zero value and if it is less than infinite, then it can be called as a power signal. So a signal can neither be a power signal or energy signal, or any signal can be an energy signal, or any signal can be a power signal, but we cannot conclude that a signal is both energy and power, right? And a signal can neither be energy nor be power signal. That is possible, but a signal shall not be an energy signal or and a power signal. Hope you understood this session. We'll discuss the next type of classification in the upcoming lecture series. Thank you for listening, students. Have a nice day. Thank you.